Hi, this is Expendable with the OpenHarrier project. This is the standby attitude indicator that I'm using in the OpenHarrier project. This is modeled after the attitude indicator that is in the RASBAM Night Attack Harrier that is in DCS. There is another version of the attitude indicator that appears in other models of Harriers that has a big ball, which, in addition to showing pitch and roll information, the ball would also show heading information. That is not modeled here. This version of the attitude indicator does not have any heading information. So let me just show you what's going on here. So roll information basically looks like this. You've got this pointer up here and the indicators on the side. Ignore the off flag for a second here. So you can see this thing rotates, and it can rotate all the way around continuously, as does the real plane. And then we can also rotate the pitch instrument, and this will rotate all the way through. I don't know if the real instrument actually rotates full 360 degrees. It may stop at some point. I'm not sure. I have to do a little bit more research for that, but this is capable of rotating all the way through. You can see when I rotate the drum, you can see the gearing back here. So you've got this drum that's geared to this stepper motor here, and then the roll axis. You won't see the animation on the gears for the roll axis because I haven't, well, that gear is, but this gear I haven't set up to rotate yet in the assembly. But this would be rotated by this gear here, which is connected to a stepper motor in the back. And then this off flag here, I don't have this set up in the assembly for animation at the moment, but this thing does retract back inside here. That is driven by this shaft here, which would most likely be a threaded shaft that's attached to a gear here, which is controlled by this stepper motor. I might have to change the gearing ratio here. This is kind of done this way to try to keep everything tight so that the whole instrument will slide into a hole in the panel. And then I still have a lot of things to do. I have to, this knob here is going to, you rotate this knob and you're going to move a reference line. Here, let me rotate this back up. Whoops. There should be a reference line here that can move up and down by the rotation of this knob. I have not designed the mechanics for that. That's strictly mechanical. That's not motorized or anything. But when you pull this knob out, it's supposed to cage the instrument, and I'm going to simulate that by putting a micro switch inside, probably inside this part right here. And then when you pull that, it'll either push the micro switch or it will release the micro switch. I haven't decided which yet. Probably use a contact switch actually for this. And then that will signal to the sim that the pull to cage has been pulled, and the sim will actually send the pitch and roll information to the instrument to reset it to the cage position. So it'll actually look like it's really caging because it'll actually do that. And it'll reset to the cage position. At least I think that's what will happen. Haven't tested that theory yet, but I think that's what's going to happen. The other thing that I haven't done yet is I need to put a Hall effect sensor here and another Hall effect sensor somewhere in here, and I'll have a magnet on the pitch drum and a magnet on the roll cylinder, and that is so that when this instrument powers up, I need to home it, which is almost the same thing as caging it, so that we know exactly the position of the rotation, or the roll drum, or roll cylinder rather, and the pitch drum. Once that is known, then I can very precisely control and know where everything is just by driving the stepper motor. I shouldn't have to recalibrate or rehome it. In theory, it should keep its position. These stepper motors, by the way, they have very precise control. There's 2048 steps per revolution, which is a lot of actually resolution for these kinds of stepper motors. And these are pretty much the cheapest stepper motors you can buy. The only thing I'm worried about is they generate some heat, and since most of this stuff is 3D printed, I am a little bit worried about the heat generation, so I'll have to do some testing once I get all this stuff 3D printed. I'll be testing it out and making sure that it's not gonna warp or melt. I suppose I could put some heat sinks on this thing too. There is some room in here. By the way, if you're wondering what these holes are, so I can get a screwdriver in here for mounting the stepper motor in there. So that's it for this video. Obviously, there's more to come.